So let's just do this and this. So no, that's not what I wanted. I wanted this. So here, a curve. So everything that resembles some kind of line in Rhino and Grasshopper is a curve. Yeah, and that's based on the principles of NURBS. If you want to look into it deeply. So if I reference a line, it's taking it. It's fine because everything that's a line or represented like this is a curve. Yeah. So that works fine. We also have a type called line, yeah? And line, set one line, go here, take this, set one line. Why is it not working? Set one line. Am I missing something, Giuseppe? Why is this not letting me select the line? I don't know. But anything.
Yeah.
It's a bit
let you draw
lines.
Yeah.
Okay.
Yeah, exactly.
Yeah. So I don't know why it's asking me to draw one rather than reference one, but if I take this and bring it here, for example, it recognizes that this curve is also a line, right?
Mm-hmm.
You see that marker?
Yeah.
But what happens if I do this? Will it recognize?
It's not going to link. But is it so that lines correspond to? If curves link to NURB surfaces, do lines link to planar surfaces?
No.
No. Okay.
Lines is a subset of curves. I think that's the best way to think about it.
Okay.
So here I have this curve, right, which is actually a curve, something curved. But if I put it into a line, it'll be like, no, what the hell you did? So a good habit to get into is always use curves.
Yeah, I was just going to ask, why ever use a line if a curve, if it
sometimes some objects like this, this outcome can be a brep, but because it might contain some additional information that is not really almost useful all the time, or it might just reduce the amount of information, so it makes things like
more streamlined.
The reason behind it is that basically storing less information. So if you draw a line, it only stores starting point XYZ and then point XYZ. If you
so
store
does that
it as
make
a
the
curve,
overall script lighter?
Yeah.
Okay.
Yeah, exactly. So it's basically a lighter. It's gonna make your code a bit lighter in the end. So it depends on the amount of of geometry you're dealing with.
Yeah.
So if your model is not huge, you can go with curves, but if you want to optimize a little bit, line is slightly better.
Yeah, exactly what you said. They said. I mean, I don't think you'll actually I don't think it'll optimize it enough for what we're doing, but
that's for like the super advanced.
There, exactly, something there.
Yeah.
And mesh, of course, you'll always have to use a mesh. These always have to use mesh surface, of course. Yeah. Breps. You can save services and breps, of course, but you can't save breps and services. So these are kind of the
raw components.
Yeah. These are the let's say the families, and then you have these different. These are the main ones right here. And then these can be used here, but So these are.
I'm gonna have to go through and make a list and a visualization because I'm gonna slip up on that.
Yeah, I mean, I don't think it'll cause you much problem, but you can see just here.
Yeah.
Like this happened to us here, right? So because this contained, it didn't really understand. It says the same thing.
Yeah. Okay. Thank you. Sorry for the interjection.
No, it's fine. Don't apologize. You're not actually being useful. So yeah, I'm hoping that's clear, right? So it gives this example's Colibri plugin just gives me all the data that I need if I want to use the Design Explorer plugin, right? Okay. So maybe I'll just show you. I mean, this is what I had in mind for the workshop. Do you guys want me to show you anything else?
My brain's gonna explode.
Your brain's gonna explode.
Yeah, like I can digest what's happened so far, but I wouldn't want to risk overloading, personally.
Risk overloading. Okay.
I'm honest. I'm being honest.
Okay. It's I think it's a good start, at least the principle. So, is there anything? Okay, so let's use this opportunity to go through something that's not very clear. So, for example, you know, the concept of a vector isn't making sense or anything. I can go over it again. Yeah, or something that's not making sense in terms of how Grasshopper works. I can try to explain. Guys, I don't want you to be kind of, I want you just to have an open discussion, right? Just be honest.
Yeah, I mean, I interjected when I had an issue, so, you know.
Yeah. Jordan?
Yeah, so with the ADD sessions, right? So that's mainly for like Grasshopper and this sort of thing. How do we turn up to those in terms of, is there something we have to have ready beforehand, or can we just go there with an image and say, how do I make this?
Okay, so with the ADD sessions, they're actually, we're actually getting very busy. So if you want, so ADD session is basically a half-an-hour drop-in if you have a specific thing that you want us to help you with, right? It's not about how I can do this. It's rather, I'm doing this. This is where I am. I need to know how to get through this hurdle, right? So don't come up with an image saying I want to do this. I want to always see like you try to do it, figure it out, and then I can help you refine it. Because in half an hour, I won't be able to kind of. There's no way in half an hour that we can go through the whole thing. So it's more of a clinic. But it'll be either me or Sol on there, or Sigita. Usually it's me and Sol. So we'll be able to help you. And it's part of the provision for this year for the MSA. So it's a useful resource if you want to take advantage.
Where are you uploading the scripts onto?
There should be on your 5th year OneDrive. Yeah. I think I already have a few things there that I uploaded and Sol uploaded that you can have a look. But I think first thing, once you understand the basics of Grasshopper and the flows, the key things you need to get your head around, right? Something called data trees. So what are the data trees? I'm hoping you all looked at the resources that I sent you. Kareem, do you know what data trees are? Do you know how to work with data trees?
Not really. I looked at the resources, I had a look through, but I wouldn't say I'm confident.
Okay, so because this is so fundamental, I'm gonna go over it. Because I want you all to be. I'm sure most of you are still not familiar with it. So I'll just go over it very quickly. So we had a workshop with Sol the other day as well, and we're talking about Python, right? So and data types. So we have an item, we have a list, and we have a data tree. So these are the three kind of data structures generally that we can have here that contain different objects. So if I just type in 1 and get a panel, so a panel helps me read the output, I can just see I have one item, right? And I can see this is an index. So it's telling me that you only have one item in this list. So you can think of this as a list with one item or just one item. Doesn't matter. Yeah, and that's just one item. Then I have a list. So here I have a list. So I have a series component, and it generates a series for me. So it starts from 0 with steps of 1 10 times. So it'll count from 0 to 10 basically. So 0, 2. Of course, it's 9 because this is considered 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So because it starts with index 0, you always get this at the end. So this is a list, and this list, it can be anything, right? So you might have a list of points. You can have a list of anything. Again, it's a overall structure to arrange your objects that you have, right? So this is a list of numbers. If you in terms of vectors, I can have a list of vectors. So this is a list of vectors here. Again, a vector is represented in three values like a point. So this is my list of vectors. Okay, now with a data tree is a nested list. So these are my points, and let's say I want to create a data tree with it. Yeah, so you'll find most of the things related to trees in this tab, which is the set tab. So some of them here and some of them here, etc. But let's say I just want to use this for now. So partition list component, if you hover over, partitions a list into sublists. So I can take a point list, size. So let's say I want a size of 5. I plug that in. I get my panel, so I can read the outcome, and you can see here what it's done is taken my list, took the first 5 items, 1, 2, 3, 4, 5, so ending with index number 4, and just made them into a separate list. And this is another list. So now I have 2 lists within my overall list. Yeah. And you can see here this path is called the data tree path. So this is the index for the item. So this is item number 0 in my list 0. But this is item number 0 in my path 0, 0. And that's because I have path 0, 1. And what this tells me is I have the second list here. Yeah. So again, everything in Python as well starts from 0, from indexing. So list number 0, item number 0 in list number 0 is this one. Item number 0 in list number 1 is this one. Yeah. And this is important because here, let's say I want to I have these lists, right? So think of it, for example, if you have a building, yeah, and you have windows in a building, and you want to apply some certain function to those, right? You'll have your list, your overall list will be your buildings, and those windows will be the items within that list, yeah? So you can think of this list here as a building, and this is the items in your building. You can think of this list here as a building, and these are the items of your building. So let's say I want to also, by the way, just to show you, you see these wires here. When it's just kind of a dark gray, it means you just have an item. If you move it down, when it has an outline, it means you have a list. So you can see here, this is an item, this is a list. And when it's dotted, it means you have a data tree, which is a nested list. Yeah? So in coding terms, it's called a nested list, like this. And this nested list can go into even bigger lists, right? So I can do partition list into items of 2, for example. Let me change this to 4. So I have 2, 2, 2, and 1, and then I'll connect this here. And now I can see this. So here I have two overall lists and the list of items within them. And then what I've done here is taken those. So each Grasshopper node applies the function, yeah, to each branch, yeah. So it doesn't apply overall. So then I've taken all those lists. So this is one list, this is second list, and I've partitioned those again. So you can see here, this is one list, another list, another list, another list. But if you pay close attention, now you have 3 values here on the top, yeah, and that's because I've separated this list into 2, but then I've separated this list here into 2 again. So this is one list as part of the 0 index, the middle index here. So these top 2 are related because they're within one list. I don't know how to explain it properly.
I understand that. I just don't understand the utility of it. That's the area where I'm like lacking.
Okay, I mean, but this is the utility of this is kind of it's the way for you to structure data. So you can't really work with Grasshopper without knowing this. I'll show you an example. So param viewer. So if I take this, let me show you this here first. So this is telling me data with 2 branches. Yeah, so this is the same data here. So it's telling me I have the data, it has 2 branches, branch 0, 0, which is this, branch 0, 1, which is this. And this has 4 values, and this has 3 values. If I right click on this, draw tree, shows me that this is my data here. And then it's branching out into these 2 separate lists, and these 2 separate lists are branching out and containing data here. Yeah. If I connect it here, you can see it's telling me I have the object. It branches out in 2 lists, and then those 2 lists branch out into further 2 lists. Yeah. So here you can see these 2 on the top are part of 1 list, separated into 2, and these 2 on the bottom are part of 1 list and separated into 2. Hence this middle value, right? So this is hierarchical. So this 0 just tells me this is all one item. The 1 here, the 0 here tells me this is part of the same list. This is part of a different list, and then the 1 here shows me this is a sublist again and a sublist again. And in terms of the value, okay, let's see. Let's try to come up with an example, right? So I have these random surfaces, guys, right? So surface, set multiple surfaces. Now, I need to apply an operation to them separately. They're not one thing, yeah. But I don't want to copy the code three times, yeah. So
okay, it just clicked. Yeah, no, I know exactly. I think I know where you're going. Yeah.
So here,
I mean, explain it all the way through, but yeah, I think I get where you're going.
So this is again the list. Everything in Grasshopper works with data trees. So this is a list. I'm giving it a surface. I want to separate each list, each surface into 5, 5, and 5. So you see here, you see what I get here? So I'm getting
the subdivision, yeah?
Yeah.
Or yeah.
So let me reduce this even more. So I just actually this is too much. Let me do this. Okay, so I'll show you the param viewer so you get an idea. So here I'm taking a surface, yeah, and if I click on this, you can see it's divided it in U and V. So U and V are local coordinates. So I'm saying divide it into 2 this way and 2 that way. So you can see there. If I increase it, you can see I've divided it into 3 ribbons, if you like, this way, and 3 ribbons that way. Yeah?
Yeah.
But then what it gives me is this. First, it looks very complicated, right? But it's actually very logical because looking at the tree branch on the top, I can see this 0, 0, 0. Okay. 0, 0, 1. Okay. 0, 0, 2, 0, 0, 3. And then it jumps to the next list. Okay, so that's not interesting for me. So I can see that I already have four of these top lists in one list. And why is it separated into 4? Do you know, Kareem?
I'm assuming because you've separated, you divided it into 2 earlier, and then you've put it into the. Wait, can you zoom into that slider on the number slider on the very left hand side, please? Yeah. Okay. So you've got the U and the V value, the U and the V count, sorry, and that divides it into 2, which separates your nest.
Doesn't divide it into 2.
Yeah, it gives you the values. So I'm thinking about it like vertically.
Oh, in terms of the nest, yes, you're right.
Yeah.
It separates it into the U and the V.
Yeah. Yeah. So that gives you a division for for each shape, and that divides it into 6, which I can see on the data tree there.
Yeah.
And then I don't know why it separates them the way it does in the list on the very right hand side. I don't know that jump.
Okay.
That's where I'm disconnected.
Anyone wanna take a shot? Lon Wailo, Jordan.
Yeah, I'm all out. I'm not sure.
in the list, you can see it's on the list on the right. It's 0, 0, 0, and then when it goes to 0, 1, it's the next shape. So is it?
Oh, 0, 1 is the next shape.
Or the next plane or something like that.
Yeah. So exactly. So 0, 0. This one, the first two, you can see the same here, right? So this is one of the surfaces, 0, 0. So you can think of it as this is shape surface 0, 0, 0, 1, 0, 2. Yeah, and that's the main separation here. Yeah? The three.
So do we have 4 values for each shape?
Yeah.
For each
So
shape,
you got 0, 1, 2, and 3. So for each shape, you divide that into 4. So you get 0, 1, 2, and 3. And each of the values that correspond to one of the divided shapes.
So how many total values do we have in that list on the very right hand side?
So for each surface, I have 4, 4, 4, 4.
Yeah. Okay. That makes a lot of sense. Okay. Sweet. Yeah. This sounds really stupid, but I think if we worked in 4 squares or 4 shapes instead of 3, because there's 4 points on each shape, it would have just, I don't know why that would have made it a little bit easier, but I think it would have.
4 shapes instead of 3.
Yeah, because I was getting lost between where we got 12 from, and it sounds really, really silly. Obviously, 3 times 4 is 12, but when you're trying to follow a million things, or what feels like a million things,
we don't have anything that's 12. Karim.
No,
where did 4?
We have?
No, it's because there's a 0. You left at the 0. It starts with 0, not 1.
So this is actually first, second, third.
Yeah.
Yeah. Again,
that's why you're looking for 3 instead of 4.
Takes some time to getting used to, but this
the index starting at 0.
Exactly. Yeah. So if I take a list item, so a list item will go through all the lists. Yeah. So it takes in the list, and I can select the index. So if I can just go here, and this will select item number 0 in all of the lists I have. So you can see here, selecting this point, this point, this point, and this point for this surface. Yeah.
Yeah. I get that they were separated. The index starting at 0.
Yeah.
It seems so basic, especially with all the Python stuff. But like,
it's fine.
Flip on one fundamental.
Takes some while to get used to. I mean, that's fine.
Yeah.
So you can see it's structured in a way where we can actually go through. We have rows. So this is actually a row of data here. Yeah. So it gives us a way for us. So let's say I want to just, I don't know, for some random reason, I want a specific row to just move up whatever, right? So move up again. I need to move with a vector. So unit Z. This basically just tells me that I need to move in the Z direction. You can see the vector that gives me 0, 0, 100, which means move up 100. Yeah. Just connect it. That's it, right? And then the rest, the other values are still there. So it gives me a way to control my data, right? In a way that's
it helps divide already divided shapes. Is that the key?
Yeah. It helps me structure everything. So once I want to apply an operation to something, I have a structure where it will just work out. And
I was viewing it as more of a data visualization tool than anything before, and I think I made like a really early assumption, and then you view it all through that lens, and that early mistake screws everything up, all the later thought processes.
Yeah. So I mean, it happens with every single person starting off. Like the thing with getting confused with 0, I see it all the time, and with the data trees and what they're used for, right? So
is it possible that I can say a set of data tree in simple terms is a set of domains and ranges that correspond to different values?
So a data tree is a list of it's a nested list. So it's a list that contains multiple lists, and those items in the list, they can all
be controlled individually.
Not you can control them individually, but it gives me the structure to work with, right? So let's say you see this. I know it's not the best example, right? But this operation that I want to do is whenever.
No, it's actually good enough because like you can control each of the values.
Whenever I have a surface, right here. See, I can always select one edge and do something to it because I have it in a structure.
And now, is this to prevent having to copy the script for each individual shape?
Yeah, and sometimes it's actually just to work with things because even if I have one, it works fine, right? But sometimes I need to do an operation on one that requires me to split it up even more. So it's not just about
maybe on different numbers of shapes and values.
So here for example, you can see, right, the data tree here. So what happens if I flatten the tree? So flattening a tree is taking a tree and destroying its structure. So if you look here, it just becomes one list. Now I can't do the same operation, right? I'll just move all the items. Yeah, I can't do this anymore here.
So then when you're applying this to like architecture and not just 2D shapes, would that mean that when you're let's say I'm working with 3 volumes, I can control them all as one volume for the general trend, like for the entire process, until I need to treat one item as a unique item, and that's when the data tree really comes in handy, or the nested list really comes in handy.
I think if you take that example, it would be you would control the global values for all of the shapes and values that you want for the whole sort of building or plates. And
yeah, that's what I mean.
If you want to dig deep to that, and then you would extract one of those values and then do another operation on that.
Yeah. So you can isolate. Later down the line.
So you can isolate later down the line, but you there's things you can't do without data trees. So I've already used this one. Domain.
I don't know if this helps you or confuses you, Kareem, but for PS1, like our towers were cylinders, so I had a brep that was one cylinder, and then I used a tree to split it up into maybe 15 floors. And each floor I split up into another subtree of 12 panels, and then each panel had perforations. So there was like 4 depths to the tree, and that organized my tower, and that meant that I could control the perforation sizes, but it was all organized and computed through Revit.
So does that mean if you were trying to customize like the size of like a facade panel,
that's exactly what I did.
Okay.
Panel
so let's say you have a data tree with every panel in one item, right? And then you have another data tree which corresponds to the radiance value for that panel. You need them both to be in the same data tree for you to match the data and actually apply an operation.
Okay. Yeah.
It's actually a good example to. I don't know if you have it ready, Thomas, to show it.
Oh God, it's a bit messy.
You're describing it like it's my bedroom.
Worse than that.
Segments. Right, what do I need to do here? I forgot. Divide surface? No. Divide domain. Segments. ISO trim. There it is. Surface domain. Oh, what's going on here? Okay, parameterize. Did you manage to get it up, Thomas, or is it too much of a hassle right now?
I'm opening it now, but it may take longer to open than we have. I'll let you know.
So why is this not working? Domain. I don't know what the exact components are. Yeah, so useful Googling exercise. So split surface into equal parts Grasshopper. Divide surface by spacing. So let's see.
I think the data there were not matching structure.
So
not? you have a list of 4 surfaces,
yep.
And let me see.
I have a list of 10 surfaces for each. I know what's wrong. It's because yeah. Okay, so surfaces. So let's try this. This again.
I mean, in general, you have to think that basically trees are just a way of organizing your data correctly, so you can always access them. That's what's going on, basically. And the tricky bit is that every time you do an operation, the input have to be organized in the same way. Otherwise, you will have some troubles. So what's the error there? If you go on the cloud, if you check on the error, maybe it will give you some hint.
Yeah.
Of what's going on.
Surface is invalid because trimming new domain is singular.
Trimming new domain. So you have 4.
I have honestly no idea why it's doing this. Domain. Hi.
Because you have,
set one, but even with one, it's not working properly.
And now it's gonna work.
No, now it's working. Why didn't it work with multiple ones? That's defeats the whole point of working with the tree. Let's try again. I think maybe one of the surfaces.
You may have needed to graft it at the beginning, the surface. Yeah, if you graft the surface at the beginning.
Of course. Okay, yeah. So again, guys. So another useful thing. Okay, so here I'm just dividing. I'm creating domains for a surface, right? Which gives me segments. So segment here is just telling me I want to divide this surface from 0 to 95, which is somewhere around here, and from 0 to 58 in the y. So here. So I want to create this domain here on the surface, right? Yeah. So it's giving me a range on the surface in the x and y. That's why this is u and v. So when you have a local coordinate system on a surface, it's u and v, not x and y. The same thing, yeah. And that's why if I do this with NURBS modeling, I can always get the domains. Anyway, so what I've done here is I've taken a domain of 2 surfaces. Yeah. So these are the 2 surfaces. And their domain, it's not going to give me, but if you hover over here, you can see the domain. So this is how the surface is represented in terms of a range of the domain, right? So u and v. But here, I'm getting into a problem. You can see I'm not dividing the surfaces properly, and that's because I have 2 different data trees. Going back to data trees, so I have a list of 2 values. Yeah. So list. Sorry, panel. No. So I have a list of 2 surfaces and a data tree where each surface was split into u and v, right? But because this is not working, you can see I can't be able to split. It's because these are 2 different data types. So I'm giving it a list and I'm giving it a data tree. And what's doing, it's kind of applying the domains to these surfaces in an unmatched way because the data is unmatched. So what I need to do here is something called Grafts. Yeah, so I'll just show you what Graft is. So grafting, you can see here, I just have a list of 2 items, but when I graft something, I make each of them into a separate tree branch. Yeah, and then with this, I can bring it here, and now the data maps correctly, right? Because you can see this is the first branch 0, 0, second branch 0, 1, and I have these 2 branches here 0, 0, 0, 1. So I need to give it the same data tree for it to work. So if I do this, and now you can see I've split every surface in 3 and 5.
Could you just re-explain grafting really quickly, please? Sorry, I don't think I caught that.
That's fine. Again, Marco, Kareem, very useful. So, so the surface, this is a list, right? Just a list of 2 surfaces. Grafting just makes it into a data tree with.
Oh, okay.
It's opposite of flattening. So flattening will completely destroy.
Flattening will compress, and then this will expand.
You shouldn't really use flattening unless necessary, because then. But anyway, never mind. But grafting, sometimes you need to use grafting for it to match. So here, the data didn't match, right? Because I had a list. Sorry, I had a list of surfaces, and then I had a domain which is grafted. So it didn't really know how to match the data. So I had to graft it. So I'm telling it the first domain goes for this surface, the second domain goes for this surface.
Yeah.
And once I've done that, it can separate, right?
I will avoid, like you said, you shouldn't use flattening. But if we do use flattening, can we just delete that node and it will undo, or is it one of those things that once it's done? Okay.
There's different ways. So I can show you here. So flattening, you can actually do flattening in frame. So you can see here, this is a data tree, right? So I have 0, 0, and 0, 1. I can right click, flatten, and it already flattens it from it. And you can see this means flattening. I can right click, unflatten, I can right click, reverse. Sometimes I just have to reverse the list. So make it upside down. Grafts. So I'm giving so now I've created an extra branch with every item. So I can do these shorthand from here.
Yeah.
I can do them from here with the set. So here, graft, flatten, and then these other ones. So unflatten is quite a useful tool sometimes. Trim tree is useful. So sometimes you just want to get rid of one branch. This is what you can do here. Yeah. So if I've grafted it here, you can see it's annoying, right? But I can actually get rid of one branch here and turn it back to what it was.
Okay.
Yeah. So these are useful here, very useful. You'll end up using them quite a bit.
Yeah. And another one that's very useful is simplify, because basically what you need to be careful all the time is that when you have a tree, each branch has a name, and that one in graph is the name of the branch. But sometimes something really annoying is that it's adding a new branch all the time. So it's adding 0 that you don't need. So if you want to delete one of those 0 which are useless, you can simplify. And the most simplify is the tree. The easiest is to manage the matching.
So you see here, right, with the name. Now I think this will get rid of the 0 right on the left.
Yeah, he only keeps the one that he needs.
So simplify tree, basically, if you're doing an operation and then the trees are getting very complicated with extra zeros, simplify tree just gets rid of the zeros, essentially. Well, it doesn't get rid of the zeros. You'll need the zeros sometimes because this index of the list is 0. But sometimes when the list gets too long here, you need to simplify just the naming of them, and this is where you use it.
Could I ask you to zoom in a bit more, please? Yeah, perfect. Just because my internet's really shoddy and it's like pixelated, so I've been trying to read, but it's strenuous on my eyes.
Okay. What were you asking for again? The name of the?
No. Just to keep it a little bit more zoomed in. My internet is really shoddy, so the screen share is very pixelated.
Okay.
I mean that's more than enough, but you could around there is perfect. Thank you. Sorry for everyone else. It's just I can't. annoying as all hell.
Your eyes are important.
I do have a question.
Sure.
For example, if you flatten the for whatever you just done on the left side of that on the left side of the screen, ISO trim, right? So like if you flatten the ISO trim, would the list be still in the small squares, or would that just turns back into the surface that you selected?
No, so if I flatten this ISO trim, so before flattening it, it was structured in a way where I have two lists. Yeah, so this is my second list, and
right.
Because they were separated, two different surfaces, right?
So if you flatten it, it just makes the small squares to one list.
Makes them all squares in one list,
right,
which is not useful if I have something here to continue doing.
Right.
Yeah.
What about if you bake it? Would the small squares be present, or would they just turn back into a huge?
So this actually gives me a surface as an output. So any geometry that I can get out, I can bake. So you're just asking whether I can bake this, yeah? So
yeah.
This.
Okay, right.
This is Rhino geometry now.
Right.
But I mean, for example, let's say this is a what's going on here?
You should always use all the time as well the param viewer, which is showing you like the tree structure, as well as yeah, that one exactly.
Param view. This is very useful.
Yeah. So for instance, here you see the branch that you need are the two green ones, but the last one is just added by Grasshopper. So if you simplify, it will stop it at the second step instead to get into the third one. Yeah.
See that? So it's the same data, just reducing the extra branches that we don't need.
Yeah.
So here again. So let's say I have. I don't want to flatten this. Where's it gone? Okay, so here. Okay, because I've selected the new. Okay, let me internalize. No, where's it? Internalize and get rid of that. Okay, so I have these surfaces, right? Lon, just to illustrate a point about data trees again. So I have these two surfaces. Let's say I want to extrude them, the different surfaces, based on whether they're more central or more out, right? So how would I do that? I need to work with trees, of course, because they're two separate things. So I can use the area component. So I'm taking the area. So the area component gives me the midpoint of my surface. You see centroid here on the area. Yeah. And then what I can do is I can use the same here, like that. Shows that. You can use the same here. So for each piece, each thing, I have a centroid again. Yeah. And then here I can do distance. So distance, I want to measure the distance between these centroids and this. But this is going to cause me a problem now because let's see what the outcome is. So panel. So this is going to cause me a problem. Do you guys know what the problem is?
It doesn't know which centroid to look for in the larger.
Exactly. So the way I have it here, and maybe.
But I can't really flatten the thing, right? Because I have two, it's two separate squares.
You can graph this. So what's it doing is for every point. So I don't know if you can see it here, but you see how some of them are very far and some are very close.
Yeah.
And that's because it's looking at it's taking the first centroid of the list and looking to the distance to the one of these. And then the second centroid and looking to the other centroid. Yeah? Because I haven't grafted it. So once I graft it, I can tell it, okay, the first half of this list, you just look at the first centroid. And the second half of this list, just look at the second centroid.
Right, so if I graft it, then it automatically links back to
because here I'm working with two different elements, so I need to make sure I always separate them out.
Right.
So then with distance, I can use the extrude command. So extrude my base, which is a surface or a curve, so that's fine. Direction, I want to give this as direction. Data from number to vector, of course. Distance, okay. Of course, I need to. Of course, when I extrude, I also need to give it a vector and not just a value, because otherwise it won't know where to extrude. Yeah, so like this.
Right.
Yeah. So you see, every point here was mapped to the surface that it needs to map to, and then it extrudes. So if I didn't graph this, I just get something completely different, right?
Right.
And okay, so basically what it's done is it's taken just one of the centroids and measured everything to one of the centroid, and then one was left behind and measured it to this one. Anyway, something wrong with that.
What if you wanted to take like the center of, I don't know how to word this, the middle of both those shapes? So instead of defining two centroids, you defined one, but between like the mean average between both the centroids, if that makes any sense.
Again, it's a bit of trigonometry. So what you need to do here is, so let's do line. Let's do poly.
So you take the mean of those 2 points, and then you make a line out of it, and then you take the middle point, and then you treat that as the centroid.
Exactly. So this time I'm not grafting it. This time I need to flatten it. This is not working because it's grafted. It's telling me how am I supposed to find distance from a point. So I'm taking this. I'm getting the.
And then you find the halfway point of that line.
Exactly. So it's actually useful because I want to show you how to just use one instead. But let's do point on line. I think it's point on curve. Sorry. So point on curve. This is my curve, and I'll show you here. Point here. Just gives me a way.
Yeah.
Right.
That's really sick. That's really cool.
So you can see how everything just flows through, right? So here, I can just pop this in here, and then every single one of these points, this is the only point they get to go through, right? So you can see there.
Cool.
Look,
Bjork Ingalls, I have figured you out.
If I make one, you can see this. This means the center point here, right? This one, and this means the center point there.
Yeah.
So
that's
I can
kind of like Ragnarok and Marvel.
dancing around. That's what I can do, right?
Like a meme, you know.
If I need 2 points, I'll do this. And you see the value of data trees now. Now, the best. I always like to work. If you know that you'll have multiple surfaces, always make sure you work with multiple surfaces, because it's very easy to work with one surface like this. Of course, sometimes it'll break because you can't. There's only one centroid, so I can't measure like this, right? And then you don't need to graph this because it doesn't make sense, and the outcome works fine. This is what you want. But as soon as you have multiple surfaces, then you want to choose here. It's not working right. So if you know you're working with multiple surfaces, so let's say you're working with different floor plates, always make sure you're working with 2 at least. I think that's a good kind of hint, because then you make sure everything works right, and then no matter how many surfaces you give it, it's streamlined. So
and if you wanted to change kind of the I don't know, the resolution of those pixels, each individual block, you'd go back to where you divided the shapes initially. Okay.
Right.
Everything feeds forward. That's the idea of parametric design. You have parameters that you can change, and you don't have to do it all over again, right? So
that click is
sorry.
Right. That is a great click. Like, I understand now.
So does it make sense in terms of data structures now?
Yeah, for sure.
Yeah.
Good. I'm glad.
Because like back in PS1, we were doing like floor plates, right? And then I was at first doing like these. I did Ladybug, and then I mapped the luminous onto the floor plate, and then to see how it can affect how I can open holes on the floor plate. But then I couldn't figure out how to do all of the floor plate at once, and to make them relate to how many light they're actually getting. So so this really clicked for me. So
yeah, I mean, see, it's kind of, it makes sense. That's why the more you use it, the more it makes sense. It's hard to explain the theory. It's just experience.
No, but this goes back to the earlier point today in the CPU breakfast discussion about like computation as a thinking tool. This is like an alternative way of kind of viewing the 3D space.
Of course. Things not just represented in lines, but relationships between things, right? Because here,
it kind of like open up a new world for you, like because you have a new tool now.
Of course.
It's like learning how to draw. It's pretty exciting, to be honest.
Yeah. So I think I'm very I'm happy that you're excited. And I think if you want to get the most out of it, you need to be excited. For me, I mean, Grasshopper is I always enjoy working on it. You know, if I just get paid to play with Grasshopper all day, that's what I'm happy to do that. It's quite fun. It's like endless opportunities. You can use it for data visualizations. You can use it for so many things, not just in architecture, right? You can even use it for product design, and it's a very very useful, powerful tool. Sometimes you'll get into roadblocks, like you won't be able to find the plugin that helps you do specific things that you want, and then you'll get into these bad boys over here, right? Where are they? Python and C#. These ones here. Then you start importing geometries and making up your own tools, and maybe publishing them, and then you can create your own plugin like these. Yeah. So not Weaverbird. The other one, what's it called?
Ladybug.
Ladybug. There it is. Oh. So Ladybug. There you are. That's how you build your own tools, guys.
Yeah, you say it like it's that simple.
Yeah, I'm just saying that in terms of the point of opening up a new world.
For sure.
I wanted to emphasize that, right? In terms of you don't become limited with I can only draw and do certain things, but I can solve things in a new way that
Yeah, I think the moment you get into code, like it just like you can create your own tools, so there's nothing limiting you anymore.
Yeah, 100%.
Yeah, except my mental capability.
Yeah.
No, trust me. It's think of it as an exercise for your brain. It's not going to destroy your brain. It's only going to make it better. Not that your brain is not.
Inshallah. You don't know what I struggle with.
This exercise that makes you. I think it makes you think about things in a different way and really.
No, for sure. This has been like pretty enlightening.
Okay. Good. I'm really happy that I brought up the data tree thing, because I didn't know it was still kind of blurry with you guys, but you can see, right? I mean, it's very important. Is there anything else? I mean, I know we're past 5 now. We should be over. Anything else you want me to cover briefly?
I think I'm just gonna go through this like 3 times and then pass out.
Do you want me to send you this file as well with the data tree so you can?
Part of me wants to say yes, and part of me wants to build it from scratch and not have like a lifeline.
Yeah, I think building it from scratch is good.
For like people that maybe do need a lifeline, like me, could you please upload it? I don't know if you could somehow.
It's fine, guys. I think just a piece of general advice: don't be intimidated, because believe it or not, this is very simple. Just think about it, right? You're just taking a surface. You're looking at the domains, the edges. You're dividing it. Everything is very clear and presented here, right? I mean, the computer, it's not like Grasshopper's got a mind of its own and it's doing something. Everything, if it does something, that you don't want, like this, that works fine. But if it's doing that, that's not Grasshopper's fault. That's your fault. There's something that you didn't do right? So it doesn't have a mind of its own. Everything is clear. It just needs a bit of time digging into the logic and how how it works, right? So, and I think with the ADD provision, I mean, we haven't had it before in the MSA, and I think it's a big opportunity, right? I mean, if you have a question midweek, Monday to Thursday, and you need an answer, and there's a slot available, you know.
Mahmood, I found the file if you want me to show it.
Okay.
If we have time.
If you show it real quick, and then we'll call it a day, yeah.
Yeah.
But I'll upload it, Sana, by the way. I'll upload it for you to look at as well.
Thank you.
Can everyone see that?
Yep.
Yep.
Yeah.
Yeah. So we had our cylinder. I'm not sure if I'll be able to find it. Well, that was the context which we used, and then we used the solo analysis, which gave us each panel. So then that went into a list over here, and each panel has a number if it was overlit or underlit. So using that list, we then took another cylinder and we split it up to 2 850mm floors. And then we divided each one of those panels into perforations or dots first, and then those dots made perforations, and they were controlled by the amount. So you can make it really not many or loads. We ended up wanting quite a few, which made it slow down a lot. And then through those perforations, I lined up the radiation list with the perforation list, and that ended up making the circles. And they varied in size dependent on if this panel got more radiation, the circles were smaller because it could do it, but if it had no sun, the circles were bigger. And then final product, you subtract the panel from the circles, and then you had a unique panel per, well, there was only 6 or so types of panels. Yeah, in the final case. I think, yeah, that's about it.
Have you just got a big geometry to show them the variation?
Yes, if it loads. Oh, nice. Yeah.
I mean, I think there's always a million ways to do one thing, right? So sometimes you might think one way is right, and you go down that route, and then you find that it doesn't work. So you have to find a different way. And sometimes there's ways that are more optimized. So you figure out that, okay, I can do this in an easier way that doesn't cause Grasshopper to crash, right? And that's part of programming. So just so you guys are aware, it's a process, and it's not just a solution that you can just pick off the shelf, right?
I think it's crashed, so that may be the end of it.
Do you mind uploading it to the Grasshopper library, Thomas?
Yeah, sure.
Yeah.
It's a bit ugly, but yeah.
It's fine. I think it's a good example to have. I can see it just loaded. But yeah, so you can see the variations that you can get, right? And this won't be possible without data trees and matching data trees. So matching solar radiation data, yeah, to the data tree of the panels that you have. And you can see the variations. There might not be much, but there is variations. On the right, they're a bit narrow, and as you go on the left, they get wider. And if you have any questions, try to ask each other as well. So usually, you know.
Yeah, Tom's just sacrificed himself there.
Yeah, welcome, guys.
A long time ago, when we used to work in studio in the good old days, we used to just
from now on
tell students to sit in the same room and just feed off each other. It's very, again, you're a cohort, and some of you might be employed with each other in the future and maybe form your own practice. So make use of each other. Yeah.
Oh, thanks.
Great, guys. Okay. I think you need a little break, so I think we'll call it a day. But
thank you very much.
No problem. So I'm hoping it's clear. I'm hoping you're gonna.